Hey everybody, this is Steve-O here, and I'm going to give a demonstration on how to efficiently resize disks for Raspberry Pis when you're messing with those. So let's get started. Um, so first, I have a 4 GB disk that it's it's actually mounted on my computer. It's a regular Rasbian Pi um, disk image, and you can find that. Let's see, find that here. Um, and the image that I have is a little old, but for these purposes, it's going to. Uh, it really doesn't matter what version it is. Um, so yeah, we have a fully extended ext4 partition that we have a Raspberry Pi, we've got it the way we want. Now we want to make a disk image. Well, a lot of times what you have happen is you start to image it, and all of a sudden I have a 4 GB disk image when all I really need is that 900 and some odd megabytes. So there's a whole lot of waste to that. There's 2.85 gigs that you don't need if you were to actually capture an image. So we're going to talk about first the GUI way to do it, and then a more programmatic way of doing it via a script that I've written that I'm going to demonstrate. Um, so without further ado, let's go through the first way of doing it. Um, and if you want to follow along or look at what the latest README looks like, you can see it on my GitHub page or in the description below once I upload this to YouTube. But for now, it's under the forensics directory playing with disk images. So that may change, but right now that's where it is. And just a brief background, we're going to be talking about sectors and blocks. And a lot of times you'll see some defaults, but if you're confused about that, there'll also be a link that you can read up on why, well, like the terminology that I'm using. Um, Nowadays, disks, there are less and less spinning disks, and things are moving towards solid state. But back in the day, disks spun, and they would read things in a circular manner. And so hard disks would have chunks that they would use to grab the data, um, sector sizes. And most of the time you'll find that these sector sizes are going to be 512 bytes. And a lot of times file systems will work in blocks that are 4096, so 4 KB. So yeah, if you want to read up about that, you can. And then I'm going to have a little calculator here that Google provides. So, um, and if you have any questions, feel free to throw them up in the stream chat. So let's get into it. So Gparted is a genome partition manager. It's a GUI-based partition. If you're using Windows, they have things that are similar, although how they would handle ext4 would probably be problematic. Even Gparted has a problem with resizing the disk, and I think maybe there's a minimum of 1 gig or something like that. But as you see here, we only have 917 megs on the disk, and if I were to do this normally, I would just like do a minimum, right? So I would tell it I want this to resize to like 918, or maybe like give it a little bit over. Um, and when I try to do this, I hit apply, it's going to throw an error. And the error that it's grumping out on is going to be that the new size is smaller than the minimum, and it gives the minimum here. So you can grab that number by trying to resize it and then grabbing the minimum, but I have a way to do that from the command line, and obviously that didn't change anything. And what we're going to do is we're going to use the resize E2FS, and we're going to tell it cat P, so print, and then the partition that we're looking at. And so it says that this is the minimum size that we can shrink this to. So we can go ahead and do that. And there's a command to do that too that's pretty simple. It's I think it's -M. All right, so now if we were to look at Gparted, we'll see that the partition size is the same, but or the file system has shrunk, but the disk is bigger. Now, if we were to tell it like check here, it would actually go back and it would say, yeah, this isn't right, and it'll fill it up. But we actually need to shrink the partition size down so that it matches what we just did. And so what we could do is let's close this. And we do dump E2FS dev mmc p2 and pipe that to less, and we'll see our block size is 4096, okay, and that our block count is 264,940. So we want to get as close as we can to the resize and the goo in the Gparted to reflect this. So what we're going to do is we're going to fire up our calculator and go 264940 times 4096. That's going to give us the byte count of that partition, and then we'll throw that in the calculator here. And it says that the megabyte is 1085. Now, if we go into Gparted and we tell it that we want to resize it, its sizes are in megabyte, and I don't necessarily agree with them having this that way, but whatever. But there is a conversion for that. So we know the bytes. We go to Google and we tell it these are our bytes, and we want to look at megabyte. So it says 1034. So we'll go ahead and round that up to 1035 when we do the resize. 1035. The reason being is we want to give us, because we're kind of eyeballing it, we do want to give ourselves a little bit of extra room here. And then hit resize and then apply. Now we hit close, and we will see that our file system checks out. And we can even run the check command. It will be just fine. Now, what we want to do is we want to make a disk image that um, will reflect this. So what you do is you right mouse click and you go to the information and you see what the last sector is. And you copy that. And then we're going to do a quick calculation for the 512 block size. And it says that this is going to be the byte size that we're going to take out of it. Now, it's really efficient to do DD with count equals 1. So we're going to use blocks of 4096. So we're going to go ahead and divide this by 4096. And we'll add a couple for, no, actually that's fine. Yeah. So we'll make this block size. Shouldn't that be? Sorry, I get stuck here with the math. I was expecting an integer, not a decimal. All right, 512 by 4096. Anyways, okay, so we have our block size. What I'm going to do is run a DD command to perform the image, because Gparted is happy now. We got that. We got that last sector. And we're multiplying that times 512, and then we're dividing by 4096, and that will give us the byte size count. And let's go ahead and pad it to 27.6, 735 to like 40. And the command that we're going to use is dd status equals progress. First, let's echo out the MMC device, the full one. And then the command is dd status equals progress. If equals, and then that block device up here, byte size equals 4096, count equals what we decided here. So we're going to do 40, and we're going to pipe that out to image.img. That's going to take a moment. Now, this is the manual way of doing it with like a GUI and stuff. I'm going to show you a more precise way of doing this in just a moment. Should finish in just a minute. All right, so now we have our image. So if we want to look at the image and verify that it looks good, we can use low setup to check it out. So Hyphen F is find the next available, and then P, capital P means I want you to scan for partitions because that's what we're doing. And we're going to mount the image that we just created. And now we're going to go into Gparted, and we're going to, well, actually we can see what it mounted it as with low setup L, and it's dev loop. So we go to Gparted, we go dev loop 0, and there you go. And if we do a file system check, it will be just fine. And now at this point, it's just a matter of piping that image to block devices, and like lining up a bunch of SD cards or what have you, and it'll be relatively efficient. Now the other part of this coin is that we're going to want to expand it, and what this looks like, and let's do that to the actual MMC, because obviously we shrunk that last time. Basically you would just do a resize move, and then you would just extend it out. And Resize E2FS does this by default, but in the GUI it's actually really simple. So we go apply, and now we've filled up our disk. So you would run something similar on the destination images if you were cloning that image to physical drives. So now let's go through the script that I ran, and this is in the source control. It's called rasbian image resize. It makes some assumptions, and actually I have something to check here because I made it argument based, and I was doing testing. So I'll commit that later. And what it does is it gives you like kind of a breakdown of what it's doing. So gives you some disclaimers, yada yada yada. But we know that our disk is dev mmc block 0. So we're going to go ahead and hit enter. And because I've already written, I've already done sudo, it's just going to go ahead and blow past all that. Let's actually look at this through less. So what this script does is it makes a backup of the partition. In case something goes wrong, you would just use this to reset the partition table. And it goes through and it does the resize based on some information that it gathered in the script. It removes the partition, and then it resets it with the new byte boundaries. And then it gives you an example of what the exact imaging command would be to do that. So obviously we already re-imaged our stuff previously. So what we're going to do is we're going to run this. I'm just going to run the whole block. Let that finish. Kind of an interesting aside. So if you look at demo, if you look at the size of the Raspbian image, it's actually 1.7 gigs. So they actually have quite a bit of, they probably have like 500, 600 megs that don't really need to be there, but that's the official, one. So, whatever. So let's go in as root and mount this image that we just made and take a look at it. Actually, low setup. Oh, we're gonna go low setup. We're gonna delete all our loopback stuffs, and then we can go low setup FP and then Gparted dev loop 0, and voila, there you go. Now, kind of as a bonus footage, so like say you want to start messing with these images, like mount it locally and then actually like do some manipulation and then repackage the image. And this size is too little from an image standpoint. It's actually pretty easy to correct. Let's destroy that. And we're gonna remove this destination image. We're gonna actually do this. As root, real quick. That was actually kind of silly. But there's actually like a really cool tip that you can use to adjust images, and that's to pad the end with zeros and then do the resize again. Um, and another interesting thing is that some of these processes can be used to recover hard disks. There's other tools that I would use for that, but once you get into it, you can actually do some pretty neat stuff. Like if you recovered a damaged hard disk and you want to like take a look at the contents or whatever, and do file system repairs, you can pretty much use low setup and stuff to um, do all that without copying it to disk. So now we're going to do L and find P, and we're going to use this destination file as our image, um, and you'll see that the block device is about 1 gig. We want to add 400 to the end. So let's go ahead and destroy it. And we're going to go dd if equals dev 0. And byte size will do 1 megabyte. And count will do 400. And then we're going to append that block to the end of the destination image. Now we're going to go through and reset up that destination image. Now let's do Gparted again. You'll see now we have an unallocated chunk, right? Now we can go ahead and, oops, expand that. Now I have a 1.4 gigabyte partition. And now I can actually mount this. So I can go mount dev loop 0p2 to rootfs. And now if I go into rootfs, I'll see all my stuff. So I can go into Pi. I can even do, so like just going as into an aside, I can even do shroot bin bash. Okay, I didn't like that. It might be an architecture issue with Pi. There's ways that you can actually like mimic you going into the operating system environment. But it didn't like that execution. So anyway, but yeah, if you wanted to like edit a bunch of stuff or go into user local bin and add some scripts and whatnot, you would just make your changes, because if you do a mount and you look here, the file system's mounted read-only. So whatever you're doing, you're actually doing to the block device live. So anyway, that's it. Looks like we didn't have any questions. I'll be posting this video to YouTube if you guys want to rewatch. So that's all I have. Thank you for watching.